Welcome to Initiatives Math class. Today our question is on binomial expansion, binomial theorem. Let's read the question together. Write down the general term in the binomial expansion of 2x plus 5y squared to the power n. If k is a constant and kx cubed y to the power 4 is a term in the binomial expansion of 2x plus 5y squared to the power n, find the values of n, r, and k. Okay, so let's start. This is how we find the general term of a binomial expansion. For instance, if I have a plus b all to the power n, the general term becomes n combination r, a to the power n minus r, and then b to the power r. So by comparing this expression to our expression given in the question, we'll be having 2x plus 5y squared all to the power n, and this will be equal to n combination r here. What is our a? By comparing, our a is 2x. That is 2x all to the power n minus r. What is our b? Our b is 5y squared. So we have 5y squared all to the power r. By expanding this and then evaluating or grouping the terms, it becomes n combination r here. From indices, 2 will be to the power n minus r, and we also have x exponent n minus r. That will give us 2 to the power n minus r, x to the power n minus r. Then over here, 5 will also pick the power r, and then y squared will also pick the power r. And that will give us 5 to the power r, y to the power 2r. Now let's group this expression here into a constant term, and then the x component and then the y component. And so this one here will give me n combination r, 2 to the power n minus r, 5 to the power r. This 5 to the power r here, and then x to the power n minus r, and then y to the power 2r. So the expression we have here is the general term of this expression. This is the general term of this expression. But from the question says if k is a constant and kx cubed y to the power 4 is a term in the binomial expansion of this, find the values of n, r, and k. So we need to compare this expression here to the term kx cubed y to the power 4. The k here is the constant. And from this expression here, we have the x term, the y term, and the whole of this becomes the constant. So k here becomes n combination r, 2 to the power n minus r, and then 5 to the power r. That will be our k, because k is a constant term, according to the question. Then x cubed, by comparing x cubed and then this thing here, this expression here, the power of the x is 3, and the power of the x here is n minus 3. So I can write this one as equation 1. I can also write x to the power n minus r equals x to the power 3 as equation 2. X to the power n minus r here and x to the power 3 as equation 2. And I can also write y to the power 2r is equal to y to the power 4 as equation 3. So these are the two expressions we are getting from this and that by comparing this expression and the expression given in the question. Okay, so from equation 3, once we have the same base, we can equate the exponent. And so it becomes 2r is equal to 4. That is from equation 3. Divide here by 2, divide here by 2. These two will cancel that, these two will cancel that. And so we have r is equal to 2. We have r is equal to 2. From equation 2, what happens here, say the base are the same, we equate the exponent. And that will give me n minus r is equal to 3. We know r to be 2. So that is n minus 2 is equal to 3. N here will be equal to 5. Now we know n to be equal to 5, r to be equal to 2. And so we can easily find our constant, which is k. What is my k now? My k here is equal to 5 combination 2, 2 to the power, n is 5, and then r is 2, so it will be 2 to the power 3. And 5 to the power r is 2, so we have 5 squared. This will give me k is equal to 5 combination 2, that is 10, 2 to the power 3 is 8, 5 squared is 25, and so I'll be having 2000 as the final answer. That brings us to the end of our solution. Thank you so much for following the Initiative Maths class. Bye-bye.